Okay. Welcome everyone to the second in a series of Moving Forward 2045 webinars hosted by SRPEDD. We're glad you could all make it today. I'm Paul Mission, Transportation Planning Manager of the Southeastern Regional Planning Economic Development District, better known as SRPEDD. I'm joined today by Lisa Estrella Pedro, the Assistant Director of Transportation Planning, and our presenter for today's topics. Additional staff responsible for today's webinar include Lilia Cabral Bernard, Lizette Gonzalez, and Gregory Gerton. Now, before we get started, I'd like to review some virtual meeting guidelines to ensure the best possible experience for all of our attendees and speakers. First, this meeting is being recorded and will be posted to SRPEDD's Moving Forward 2045 webpage. If you require closed captioning, please click on the red or blue otter.ai button located at the top left area of your screen. A new window will appear with the live closed captioning. We ask that all participants please remain muted and turn off your video until the Q&A portion of the webinar. To participate in the Q&A portion of the webinar, please use the raised hand function. You can find this by clicking on the participants button at the bottom of your screen. A window will pop up with a raised hand button, and the presenters will then call on the participants. Feel free to type a question or comment into the chat window, and we will address as many of those questions as we can during the Q&A. And if you're attending by phone, please use the *6 button to toggle the mute and *9 to raise your hand. So, we are the Southeastern Regional Planning and Economic Development District. Our agency serves a region of 27 municipalities in southeastern Massachusetts. Our work is place-based and community-focused, meaning that we work to formulate and implement plans that will achieve real quality of life on the ground and to ensure that these plans reflect the expressed needs of civically engaged local communities. Our agency consists of several departments, including economic development, homeland security, comprehensive planning with a focus on housing, land use, and the environment, and then finally, transportation. As a whole, SRPEDD functions as a team with planners that bring a diversity of professional backgrounds and areas of expertise to our agency and region. SRPEDD emphasizes partnerships with the communities that we serve, but we also emphasize partnerships with the state and federal government, nonprofits and community groups, and with citizens across southeastern Massachusetts. Our work includes community master plans, economic development, planning for all aspects and modes of transportation, habitat restoration, watershed protection, fiscal impact scenarios, drone surveys, 3D interior photography, and so much more. Every 4 years, SRPEDD develops a regional transportation plan, which is a blueprint of our existing and future transportation system. The plan examines every facet of transportation, including infrastructure, travel patterns, public transportation, freight movement, airports, as well as bicycle and pedestrian facilities. The plan assesses our future transportation needs and identifies the necessary improvements to enhance our transportation system to the year 2045. SRPEDD provides this series of webinars to ask ourselves the important questions that can guide and help us with our thinking as an agency as well as a region moving forward. Today's webinar examines the means towards a safer transportation system for all users, not just as motorists, but also as bicyclists, pedestrians, and those who use public transportation. And with all that, I would like to now introduce our main presenter and the moderator for today's webinar, Lisa Estrella Pedro. Lisa is the Assistant Director of Transportation Planning at SRPEDD with over 23 years of experience in the transportation planning field. Lisa?
Thanks for the introduction, Paul. And once again, thanks for joining us to discuss safety today. We look forward to sharing our insight with you and obtaining your feedback. We'll start by discussing SRPEDD's role in safety, our top 100 most dangerous intersections, and finish with how we should rethink safety improvements and move forward. Safety has been at the forefront of everything we do at SRPEDD for a very long time. In the 1980s, SRPEDD began identifying high crash locations as a standalone publication to bring awareness to communities to investigate and implement remedies, and to the public to highlight areas of concern where extra caution should be taken. Our goal back then and now is to reduce the number of crashes on our roadways, as well as to assist our communities and the state in reducing the number of injury and fatal crashes to zero and helping to meet Vision Zero goals. In 1985, we began identifying the most dangerous intersections in our region. We started with the top 25 locations. In 1997, we expanded our list to what we currently look at on a 3-year basis, the 100 most dangerous intersections. Through the years and in our regional transportation plan, we have also identified lane departure, red light running, pedestrian, and bicycle high crash locations. In addition to identifying the most dangerous intersections and roadways in our region, we also assist our communities with tech memos, road safety audits, safety studies, and comprehensive corridor studies. We recommend improvements and are available to assist and guide communities through the implementation process. Our most recent publication focuses on the top 100 most dangerous intersection in the region based on 2017 through 2019 crash data, which is pre-pandemic. The reason that we mention pre-pandemic is that we are aware that the pandemic has affected the number of crashes based on a shift in traffic and driver behaviors. Through the years, SRPEDD has established a database of almost 600 intersections that is updated with crash totals and assists in identifying the most dangerous intersections in our region. When analyzing individual intersections, we typically use a 250-foot buffer. We expand our analysis beyond the intersection approaches to capture crashes that occur within the intersection's environment due to such things as congestion and curb cuts. Crash severity plays an important role in ranking the most dangerous intersections. Our methodology is known as the equivalent property damage only, or EPDO. The EPDO considers frequency and severity of crashes and assigns a score at each location. Fatal and injury crashes are given more importance and a high weighting factor in the ranking process. To obtain a yearly average, the calculated score is divided by the number of analysis years, which in our case is 3. Intersections with higher EPDO scores will be found at the top of the list, making them prime candidates for further analysis and study. Comparing the locations of Washington Street at East Britannia Street in Taunton and Taunton Street at Messenger Street in Plainville, the first location had 56 crashes, 30 property damage only, and 26 injury. The second location had 102 crashes, 89 property damage only, and 13 injury. Although there were almost double the number of crashes at the Plainville intersection, it falls below the Taunton intersection in ranking because the crashes at Taunton Street and Messenger Street are mostly property damage. Further investigation into our top 100 most dangerous intersection in the region showed us that 72% of all crashes were property damage only, 27.8% were injury, and 0.2% resulted in fatalities. Taking a closer look at the type of crashes occurring, 40.8% were angle crashes, 34.8% were rear-enders, 11% were same direction side swipes, and 7.4% were single vehicle crashes. Angle crashes resulted in 540 injury crashes and 4 fatalities. Driver contributing circumstances noted for 58% of these crashes included failure to yield right of way, inattention, distraction, and disregarding a traffic sign and/or a signal. Contributing road circumstances were noted as traffic congestion and road surface conditions such as wet, icy, snow, and slush due to weather. The most common type of angle crash is the right angle, also known as the T-bone crash. These crashes occur when vehicles traveling perpendicularly collide. Right angle crashes occur at signalized intersection when someone violates or runs the red light. This type of violation can also be attributed to congestion. Motorists often run red lights because they think that they can beat the yellow. They are in a hurry, or they feel impatient because they've been sitting in a traffic signal for way too long. At unsignalized intersections, right angle crashes often occur when a motorist on a side street, often under stop control, misjudges its chance to travel into the intersection. In addition to misjudgment, oftentimes, the motorist's sight distance is impaired by obstacles such as shrubbery, fences, and parked vehicles in urban areas. Another type of identified angle crash occurs when a motorist traveling straight ahead collides with a vehicle making a turn, either left or right. Once again, the major contributing circumstance associated with these types of crashes is misjudgment, also identified as fail to yield right of way. It is extremely important to conduct a detailed crash analysis to determine specific causes, whether it be roadway deficiencies or driver behaviors, to help select appropriate countermeasures. To address large volumes of left turns at signalized intersection in the absence of a left turn phase, a left turn phase should be installed into the signal system. To address inadequate signal timing, consideration should be given to adjust the traffic signal yellow and all red change interval timings. To address driver behaviors, consideration should be given to the passage of legislation to allow automated speed enforcement in Massachusetts. To address sight distance issues at unsignalized intersections, consideration should be given to the removal of sight distance obstacles, which could include restricted parking. To address intersection visibility, particularly in rural areas, the installation of a warning sign could be considered to advise through traffic that a stopped vehicle is at the intersection and may enter. To increase the visibility of stop signs, several modifications could be made. Larger and higher reflectivity signs could be installed. Reflective material could be added to the stop sign post. LEDs could be added around the stop sign face, and double stop signs could be installed at the approach. The second highest crash configuration found among our top 100 locations were rear enders, which accounted for approximately 35% of the crashes and resulted in 384 injury crashes. Driver contributing circumstances were noted for 60% of these crashes. These circumstances included inattention and distraction, following too closely, and operating a vehicle in a reckless or aggressive manner. Road contributing circumstances included road surface condition and traffic congestion, and were noted for approximately 7% of these crashes. Rear end crashes, regardless of where they occur, are the outcome of following too closely, often due to a motorist being distracted, as validated by the previously mentioned statistics for driver contributing circumstances. The probability of rear enders escalates when weather affects the road surface and a motorist does not leave a safe distance between their vehicle and the vehicle in front of them to stop safely. To address inadequate signal timing, consideration should be given to adjust the yellow and red phase and progression through a set of signalized intersections if applicable. To help with the visibility of signals, overhead signals, large signal lenses, visors and or back plates, as well as additional signal heads, one per lane, could be installed if they are not currently included in the signal system. As a last resort, relocation of the signal could be considered. To address poor visibility at unsignalized intersections, consideration could be given to the installation of improved warning signs and or a flashing signal. The third most noted crash configuration among the top 100 intersections is same direction sideswipe crashes, which accounted for 11% of the crashes, with 32 of these resulting in injury. Driver contributing circumstances were noted in 41% of these crashes as failure to keep in proper lane, inattention, distraction, and failure to yield right of way. Road contributing circumstances were noted in 5% of these crashes as traffic congestion and work zone. Same direction sideswipes are the outcome of two vehicles traveling in the same direction, where the impact occurs along the surface of the vehicle parallel to the direction of travel. They are generally caused by unsafe lane changes, a last-minute decision to be in a turn lane or access a business, blind spots, not checking mirrors, aggressive driving, and driving too fast for weather, road, or traffic conditions. Although these crashes are generally due to driver circumstances, there are countermeasures that could be considered to remedy known reoccurring issues with accessing turn lanes. For example, if there is a high number of vehicles attempting to access a left turn lane, consideration should be given to determine if a double left turn lane is warranted. The same can be said if a high number of sideswipe crashes occur due to vehicles attempting to access the outer right lane to make a right turn. Consideration should be given to determine if a right turn lane is warranted. The final crash configuration for discussion today at our top 100 locations are single vehicle crashes, which accounted for approximately 7.5% of total crashes, with 115 resulting in injury and 2 fatalities. Driver contributing circumstances were noted for 27% of these crashes and included inattention, distraction, failure to keep in proper lane, operating a vehicle in a reckless or aggressive manner, and swerving. Road surface was noted as a contributing circumstance in 26 of these crashes. Single vehicle crashes can be the outcome of many variables, including driver circumstances such as driving under the influence of drugs and/or alcohol, speeding, distraction, and fatigue. The roadway environment can also play a role in single vehicle crashes, particularly with obstructions located too close to the road and poor lighting and road surface due to weather. Countermeasures that could be considered to address the previously mentioned issues include relocation or removal of obstructions too close to the roadway, as well as including reflective paint and/or reflectors on the obstruction. Improved lighting and drainage could also be considered based on the outcome of the analysis, if warranted. As we develop projects to address documented concerns, we need to talk about rethinking safety so that we are proactive instead of reactive. In the past, we've been focused mainly on analyzing and improving our infrastructure to accommodate the automobile. We need to broaden our areas of concern to include the safe travel of vulnerable users, bicyclists, pedestrians, etc., at our intersections and along our roadways. We need to move from concentrating on our most dangerous locations or hotspots and start addressing areas of deficiencies before injuries and deaths occur. We also need to get ahead of the problem, and one way to do that is with a systemic approach. The systemic approach focuses on evaluating an entire system using a defined set of criteria and on both crash experience and potential. It's an alternate, data-driven process that looks at crash history and identifies recurring safety issues and highlights problems with roadway features. It analyzes low-cost countermeasures that would benefit a high crash experience and its cost effectiveness in applying it system-wide, as opposed to one isolated location. The systemic analysis leads to widespread implementation of safety measures at many locations to reduce the potential for severe crashes. Many of our communities have participated in implementing low-cost safety enhancements through MassDOT and the systemic approach to address crashes at various locations. To reduce fatal and injury crashes at intersections, the installation of sign and pavement markings was implemented as stop control intersections across the state. These improvements have been known to reduce crashes by 40%. 9 SRPEDD communities took advantage of this program that resulted in improvements to 45 intersections. MassDOT also developed a systemic low-cost strategy to address lane departure crashes at locally owned high crash curve locations by adding additional curve warning signage. In the SRPEDD region, 7 communities took advantage of this program. To address left-turning vehicle crashes at signalized intersections, which are most likely to cause injury or fatalities, MassDOT pursued the conversion of the traditional signal display to the flashing yellow arrow. These improvements were deployed at all eligible traffic signals on the state highway system. There were 30 locations in the SRPEDD region and 14 communities that benefited from these improvements. Studies have shown that on average, left-turn crashes are reduced by approximately 20% with the flashing yellow arrow signal. Continuation of the systemic approach as it relates to vulnerable users should be pursued and expanded to help us be more proactive and less reactive. We also need to continually pursue a concept that has been in existence since the early days of the National Safety Council in 1925, known as the 3 E's of safety: engineering, enforcement, and education. Engineering. One way to protect vulnerable users on the engineering front is through redesign of our infrastructure, whether it be the reconstruction of an intersection or roadway, as well as creating safe off-road accommodations. MassDOT has implemented the Healthy Transportation Policy Directive to assist, as well as to encourage more pedestrian, bicycle, and transit trips. They have a principal mode shift goal that seeks to triple the distance traveled by walking, biking, and transit by 2030. The policy ensures that all MassDOT projects are designed and implemented to provide safe and comfortable, healthy transportation options at all MassDOT facilities and in all services they provide. Enforcement. On the enforcement side, we need to assist our police departments in having just cause to hand out violations and provide them with additional funding for targeted enforcement for all roadway users. The passage of the hands-free law on February 23rd, 2020, prohibits operators of motor vehicles from using any electronic devices, including mobile telephones, unless the device is used in the hands-free mode. The first offense yields a $100 fine. The second, a $250 fine, plus mandatory completion of a distracted driving educational program. The third and subsequent offenses results in a $500 fine, plus an insurance surcharge and mandatory completion of distracted driving educational program. As of June 21st, 2021, the Registry of Motor Vehicles has recorded over 53,000 total citations issued for violations since the law took effect. Over 40,000 of these were warnings and over 13,000 were finable citations. Pedestrians also need to be held responsible for their actions when they break the law. Massachusetts' current fine for breaking pedestrian traffic laws, commonly known as jaywalking, is a $1 fine for the first, second, or third offense, and $2 for a fourth and subsequent offense. The fines have remained the same since it was first enacted in 1962. Although the fines are historically low in heavy trafficked areas with appropriate crosswalks, violations should still be accountable. As for specific age groups, Massachusetts has the junior operating license requirement in place to address young drivers, but nothing specifically for older adults. Although it is a sensitive subject, it is certainly one that needs attention and additional discussion. Currently, only 2 states require motorists over the age of 75 to retake a road test. Education. Similar to any professional field, continued education is an important component to safety. It is vital to continue to remind and highlight the rules of the road for all users so that they are responsible for their actions and follow the rules of the road. Going forward, it's important that all safety stakeholders work together to create a safe transportation network. We need to consider adopting the safe systems approach to eliminate fatal and serious injuries for all road users. The concept refers to an intentional approach to help attain a goal of 0 deaths. It recognizes that humans make mistakes and that all traffic safety stakeholders, road designers, vehicle manufacturers, policymakers, enforcement agencies, families, workplaces, and even schools are responsible for reducing crashes. The ideal transportation system under this approach promotes safe road user behaviors and protects all road users from physical harm. The 3 E's will play a major role in this type of system, as we will need to focus more on engineering and roadway design components to address driver error. Enforcement will need backup, particularly in the form of legislation, such as allowing red light running video enforcement, pursuing a primary seatbelt law, and mandating retesting for older drivers. And the need for continued education will play a key role in the reinforcement of the traffic rules to keep everyone safe. This wraps up our presentation. We welcome questions, thoughts, and comments. And as you provide your comments, we're going to bring up a map that we've been using for our outreach. If the comments are site-specific, we'll put those in the map. In the chat, there will be links posted for this map, as well as for our survey that you can access once this webinar is over. And now we welcome questions.
Does anyone have any questions? If so, please use the raise hand function and we'll address them. Lisa, I just had one question. I know we just have published our top 100, but would you have the overall percentage of crashes that are a result of driver error versus other causes for the crashes?
Sure. So there are a large number of variables as far as driver error that are all included in this, whether they are distracted by something outside of the vehicle or manual operation of electronic device. We do have those numbers broken down. But overall, it was, of all the crashes that occurred at the top 100 locations, 7.25%.
I'd also like to point out that in the chat box, there are links to the mapping exercise that you can access, and I'll link to the project website for this series of webinars.
I'd also like to point out that part of our efforts here today are really to encourage people to think about these aspects of safety on our roads and really share their experiences along either some of the roads that we mentioned, whether they be in the top 100 or something that you really want to call attention to. When we think about this mapping exercise, we really see it as a tool for sharing areas in our region, in your town, in your neighborhood that you experience challenges, and maybe you have a solution in mind that you want to share with us. Part of the regional transportation plan is really getting that public feedback in order to recommend those improvements, those policy changes, whatever they may be, in order to achieve an ideal outcome. So we want to take some time to show this. Maybe you have some time to think about it a little bit later. You don't have to share now, but we do appreciate any comments that you might have.
So any questions from the audience? Don't be shy. One thing I would like to point out that the SRPEDD staff has done, not only with this crash data, but also with congestion data, is we initiated a pilot program to do an evaluation of a intersection location. And that was recently reconstructed. And fortunately, we had information prior to the construction, because it was a TIP project, Transportation Improvement Program project. And we took the liberty of also collecting data post-construction. And that was for the location of County Street at Hart Street here in Taunton. The results of the analysis not only showed that the new configuration and new signal system improved the emissions by reducing the total amount of emissions that are generated from cars that are going through the intersection, but it also indicated a reduction in crashes. And with that, it is a positive note, knowing that our TIP projects are not only improving the air quality, but also improving driver safety, as well as for safety for all users in and around that intersection. And this is a program that we're going to continue going forward as part of our performance measure metrics and evaluations as part of our Unified Planning Work Program. It's not to point out what's working or not working, but in many cases to validate that the need for these projects remains, and that they do end up providing more good. So just wanted to point it out with that. Our top 100 will certainly be a mechanism for us to begin identifying new projects for consideration with Transportation Improvement Program. And then also with that, once construction is complete, we'll be able to do what we call as-built evaluation of that construction to determine the value of the project, the safety value and congestion value. Okay. I guess we have plenty of time, so if anybody else has a comment or a question, please feel free to speak up. We welcome any comments at this time. We have plenty of time left before the 2 o'clock hour. So, you know, don't be shy. Well, seeing that there's no other questions, does any of the staff have any comments that they would like to share before we sign off today? And none? Yeah, go ahead, Lisa.
I was just going to say, I want to thank everyone again for joining us today. My contact information is up on the screen. Would like to remind you that there is a map moving forward survey. If you could please take some time to fill that out, we'd appreciate it. And we're always available beyond this webinar. Oh, there's a hand up. Robert?
Hey, good afternoon, everyone. Just a question, and you might have stated it, I just might have missed it. Are you considering data from limited access highways in your study?
Based on the data that we're analyzing, no. But as far as when we look at systemic approaches, we look at the crashes across all roadways. So they would be considered in that analysis.
Okay. Thank you.
Thank you.
Thank you.
I don't see any more questions. So with that, we can probably close up the webinar. And please feel free to stay in touch.
And also, please feel free to explore our website with more information, not only on this particular webinar, but also for other subject matter related to the Regional Transportation Plan. We do have a survey that we would like you to participate in. If you have some time, that would be great. And also the mapping exercise. That's all can be located on our website, SRPEDD.org. And if you have any questions, feel free to not only email Lisa, but also myself or any of the staff at SRPEDD. Our email addresses are also provided at our website. And also, please check out our Facebook page. We always appreciate a like so that you can follow us, and we can be sure to be sending out more information as our regional transportation plan develops. And I thank you all for attending today, and enjoy the rest of your afternoon.